Hello guys, good morning to all. Guys, you all are welcome on my YouTube channel Learn Chemistry with Dr. PLS. Today we are going to learn IUPAC and common names of some dicarboxylic acids and their structures. This topic is very important and is useful to draw various structures of chemical compounds. Okay, so let's start. Here I'm going to write oxalic acid. The common name will be oxalic acid. Oxalic acid. Okay, this is oxalic acid, and the chemical structure of oxalic acid is COOH and COOH. This will be oxalic acid, and the IUPAC name of this compound is, two carbons are there, so the IUPAC name will be hexane dioic acid. Hexane dioic acid. Okay, hexane dioic acid. Next one is malonic acid. Malonic acid. The chemical formula of this malonic acid is COOH, COOH, same like this, but in malonic acid number of CH2 group will be 1 CH2 group, like this. So this will be malonic acid, and the IUPAC name of this malonic acid will be, here you can see total number of carbon are 3. So the IUPAC name of this compound will be propane dioic acid. Propane dioic acid. Okay, next one is, I think I should draw this malonic acid little bit upper state. See here, like malonic acid. Malonic acid. Okay. Now next one is succinic acid. Succinic acid. Now the chemical structure or the chemical formula of the succinic acid will be same COH like above. 2 COH will be there, and the difference will be in the number of CH2. So here number of CH2 will be 2. Okay, here 2 CH2 will be there. So total number of carbons are 1, 2, 3 and 4. 4 carbons are there. So the IUPAC name will be butane dioic acid. Butane dioic acid. Clear? So in these structures the difference is in number of CH2 only, and I'm writing all these structures here so that you can learn these easily, and finally at the last I'll give you some formula type something, and by which you can learn all these. Okay, so next one is glutaric acid. Glutaric acid, and the formula of glutaric acid, obviously 2 COH will be there, COOH, and the difference will be in number of CH2. So the number of CH2 in glutaric acid will be 3. Total number of carbon will be 3, 4 and 5. 5 carbons. So IUPAC name will be pentane dioic acid. Pentane dioic acid. Pentane dioic acid. Next one is adipic acid. Adipic acid. This is the adipic acid which is used to form nylon 66. Okay, so total number of carbon in adipic acid is 6, or if we talk about the number of CH2 groups, then number of CH2 group in adipic acid will be 4. So COOH and COOH, CH2. How many CH2? 4 CH2. Total number of carbon are 6. So IUPAC name of this adipic acid is hexane dioic acid. Dioic acid. Clear? Next one is Pimelic acid. Pimelic acid. The chemical formula, what will be the chemical formula? COOH. COOH. You can easily identify that number of CS2. Here the number of CS2 will be 5. See, the sequence is there. 1 CS2, 2 CS2, 3 CS2, here 4 CS2 and here 5 CS2. Total number of carbon are 7. So the IUPAC name will be heptane dioic acid. Heptane dioic acid. Okay. Next one is subbaric acid. Subbaric acid. The formula of subbaric acid, chemical formula of subbaric acid will be same like this. You can draw COOH, COOH, 2 COH and here CS2. But the number of CS2 will be 6 and total number of carbon is 8. So the IUPAC name is octane dioic acid. Octane dioic acid. Next one is azelaic acid. Next one is azelaic acid. A structure of azelaic acid is COOH, COOH and CS2. How many CS2? 6. Then here 7 CS2. Okay. And the IUPAC name is, number of carbon is 6, 7, 8, 4, 5, 6. So here 7, 7, 8, 9. So it will be nonane dioic acid. Nonane dioic acid. And finally the last one is sebacic acid. Sebacic acid. Formula will be sebacic acid, same COH and COOH, CS2. How many CS2? 8 CS2 will be here. So this is sebacic acid and the IUPAC name will be decane dioic acid. Decane dioic acid. Decane dioic acid. Okay. Now, if I number these, then this is like I'm writing 1, 2, 3, 4, 5, 6, 7, 8, 9. Total 9 common names, their chemical formulas and their IUPAC names are here. So we have to learn these. Learn in the sense we knows IUPAC name. There is no problem for learning these because number of carbons are 2. Then, sorry, it is not hexanoic, it is ethanoic acid. Ethane dioic acid. This is propane dioic acid. Number of carbon is 2, then it will be ethane dioic acid. Number of carbon, total number of carbon is 3. So the name of this compound will be propane dioic acid. Likewise, if number of carbon is 4, then butane dioic acid. If number of carbon is 5, then pentane dioic acid. Number of carbon is 6, then hexane dioic acid. Number of carbons, total number of carbons are 7, then heptane dioic acid. If total number of carbon is 8, then the IUPAC name of this compound will be octane dioic acid. Likewise, if number of carbon will be 9, then nonane dioic acid, and number of carbon will be 8, then the IUPAC name will be decane dicarboxylic acid. Okay, decane dioic acid. What will say? Decane dioic acid, not carboxylic acid. So these are IUPAC names. These all are IUPAC names, and if you know the structure, you can write the IUPAC names. Now the matter is, how can we remember the common names of these compounds and related structures? Okay, so first of all, we have to learn these oxalic, malonic, succinic, glutaric, adipic, pimelic, subbaric, azelaic and succinic acid. And here I am writing for oxalic acid O, malonic acid M, for succinic acid S, for glutaric acid G. Likewise, adipic A, pimalic P, subaric S, azelaic A, and sebacic acid S. Okay, if I pronounce this, then this will be Ohm's gap SAS, like this. Ohm's gap SAS. This is Ohm's gap SAS. If you learn this Ohm's gap SAS, then you can learn all the structures. And in oxalic acid, number of CH2 is 0. Means here only two COH are present, but number of CH2 is 0. So I can write here number of CH2. How many number of CH2? 0. In malonic acid, how many number of CH2 are there? Only one CH2. So I will write here 1. In succinic acid, number of CH2 are 2. In glutaric acid, number of CH2 are 3. In adipic acid, number of CH2 4. In pimalic 5. Likewise, in subaric 6, azelaic 7, and sebacic acid, number of CH2 is 8. So guys, if you learn these, first of all, Ohm's gap SAS. Ohm's gap SAS. In ohms, number of CH2 is 0. Means you can say O0. If you learn these, Ohm's gap SAS and number of CH2, then you can draw these all 9 structures easily. Okay. Now, if we talk about the common names, then this is oxalic acid, malonic, succinic, glutaric. Adipic, you have some confusion in adipic acid and azelaic acid. So this is adipic acid. You can remember number of carbon are 6, total number of carbon are 6, and adipic acid is used to form the nylon 66. Okay, nylon 66. If you learn this formula, Ohm's gap SAS, then definitely first this A means adipic acid, and here number of CH2 will be 6, and this is used for forming nylon. Okay, nylon 66. And another A is for azelaic acid. So first A is adipic acid, in which number of carbon are 6, that will be azelaic acid, and the number of carbon, total number of carbon is 7, then that will be azelaic acid. Okay, and the second one thing is like succinic. If number of carbons are 2, then succinic acid. Number of carbons are 6, then sebacic acid. Number of carbons not, number of CH2 groups are 6, then sebacic acid. And if number of CH2 groups is 8, then this will be sebacic acid. So 8 is coming at the last, means in decan dicarboxylic acid, or we can say decan dioic acid, in which number of CH2 is 8, and this is coming at the last. It means reaching till here, I am feeling tired, and my sebaceous glands are start sweating. Okay, like I'm full of sweats because of my sebaceous glands. So this is coming at the last, and you can connect with sebaceous glands. So this is sebacic acid coming at the last. I'm tired, lot of sweat is coming. So at the last, what will you come? Sebacic acid. Sebacic acid. You can learn succinic acid and subaric acid. For these, you have to little bit, like you have to try some 2-3 times, and this sebacic acid you can learn. So guys, this is whole, and we are going to take a quick review again. Okay, now if we'll talk about the oxalic acid, what will be the structure of oxalic acid? Oxalic acid, number of CH2 will be 0, so the structure is COH. IUPAC name, I think you won't be having problem. Ethane dioic acid will be the IUPAC name. That is simple. But here oxalic acid, number of CH2 will be 0. So COH. If we talk about the malonic acid, the number of CH2 is 1. Okay, number of CH2 is 1. So the formula will be COH, and CH2. Okay, we can write here 1, but if one CH2 is there, then no need to write 1. Okay, now next one is succinic acid. Ohm's gap SAS. So this S means succinic acid, and succinic acid, number of CH2 will be 2. So COH, and CH2 whole twice, means 2 CH2 will be there. Likewise, in glutaric, number of CH2 will be 3. Adipic, number of CH2 will be 4. Pimalic, number of CH2 is 5. In subaric, number of CH2 is 6. In azelaic acid, number of CH2 will be 7. And in sebacic acid, it is coming at the last, and I am feeling tired, and I'm full of sweats because my sebaceous glands are starting secretion. So likewise, you can learn that sebacic acid comes at the last, and as sebacic acid means number of CS2 will be 8. Okay, so this is sebacic acid. So likewise, guys, you can learn all these common names, chemical formulas, and IUPAC names also. What you have to learn is, the important point of this is this table. This table, if you learn this, okay, what is this? Oxalic means 0, malonic means 1, what? CS2. Oxalic means 0 CS2, malonic means 1, succinic means 2. Okay, these you can learn in sequence, Ohm's gap SARS. So what you have to do is just learn Ohm's gap SARS. This formula will make you learn all these chemical formulas and their names, common as well as IUPAC name. So you will be able to learn these formulas and related structures of these formulas. Like in our next class, I'll talk about succinic anhydride, succinamide. So these structures or these names that time will be easy. Okay, so this is from me. Okay, what can I say is, so guys, if you like this class, please click on the like button, share with your friends, and if you want to get these type of videos, then subscribe to the channel. Thank you.